Hello and good morning, dear listeners. My name is Peter, and this is yet another recap of the Soliverse podcast. On this episode, we will be recapping guests of April in this particular order. Firstly, we will have a small snippet from Miguel Galatas from nTeaser, which will be followed by a small clip from Shane Lebow from PVComplete, and we will finish with Grana of Folsom Labs and Helioscope. Please enjoy.
1, 2, 3, 4.
Yeah, but you guys actually put something like a ChatGPT speeded up version of a typical startup journey, right? You build the MVP, which has been validated automatically, and then actually you technically sign the first deal. So that's really the exception than the rule, right?
Exactly. It's very different, but it kind of always talks about that when you go to startup schools or business schools, the first book they give you is the book called Lean Startup, which basically the thesis is build an MVP, build the basic project that you can do and try to sell it and see if someone buys it. And Grana said, I was so lean, I started the book and left it halfway because that's how efficient I am. So it's very much so that you have to start with the simplest thing. We started with no code. So kind of included everything on low code, no code basis using Bubble. So no real JavaScript or Python or HTML, just super simple, not drag and drop, but very, very close to it, and building the most basic thing. And when we went out there and started telling investors, first clients, they started freaking out because they thought our no code was the most innovative thing they have ever heard of. This was before ChatGPT, to be honest. And the second thing was, and also quite funny about it, is when we started thinking about who to hire, when we started building, we thought about hiring a no-code programmer and just keeping the no-code. But at the end, it just makes sense to go into real code because it is faster, it is more efficient, and it allows you more flexibility, and that's important as you go and you build. And right now we have over 400 companies as clients, so we need something that offers a good solution. But originally, it was no code, drag and drops. I would tell Carmen, I want this color change. She would go in, touch a button, the color would change. And that's very much what you need to sell. And then if it works, then you change.
Yeah, and I mean, that actually brings me back to a lesson I learned in my career as well. So I'm a sales guy, so I'm not exactly the technical person, right? And then sometimes you get stuck in this loop of building stuff for the sake of building instead of solving the real problem. And you guys really turned this upside down and you approached it from the right direction.
Yeah, and also many times you become very professional. Like you want to have everything perfect. And something very important is being good. One motto that we keep saying is the good is the enemy of the perfect. Because if you focus on being perfect, you become so inefficient and you start working so that you don't get there. Or you slow down. It's much more important to just be good enough. And if you're good enough, and if it's 90% there, of course, there's certain things in life that you have to be 99, 100% right. But there's many things in life that you're spending way too much time to make it perfect, and just make it good and sell it. You're probably, everyone who knows what startups should watch Silicon Valley and in HBO, the series.
Yes.
It's a wonderful series. It's very real because everything that's happened there has happened to us a couple of times already. And one thing they highlight when they talk a lot about building a startup and being perfectionist and highlighting is the idea of, hey, it's more important to get to be in market and to be able to sell than it is to build a perfect product. I remember this episode once where they say, hey, I got you the best sales guys in the world. Now bring them the product so they can sell. And they say, okay, we're going to make this mediocre product. And they say, no, you have to give them the best product in the world and they say, but if they're the best sales guys in the world, why can't they sell a mediocre product? Why do they need the best product? They say, no, you have to give them something easy to sell so they don't go to a different company because they want to do something easy. But in many ways, if you want to be a good salesperson, you got to sell something that is good. And it doesn't have to be great. Of course, you have to offer value, but at the same time, you also have to be able to know when it's good enough and when you're not overspending time in improving a product. If it's good to go to market, just throw it to market. And if you launch in something and it's perfect, you launch it too late. Like you wasted too much time. Launch it and see how the world reflects. throw stuff at the wall and see what sticks.
I can only echo that. I've seen that many times, and usually I'm the sales guy, and then the job of the sales guy is to balance the promises with reality, right? So you always want to kind of under promise and over deliver, but in some companies, it comes out the other way around. So it's quite a tricky situation, but I agree with you on the startup side of things for sure.
Yes, and have in mind that things are going to improve, and you have to know that, but also you can't live in your dreams. Like, for example, many things we were selling originally, I would be ashamed to sell it right now because the company has grown and we're going much more professional, and the service is 100 times better than when it was just two of us. Obviously, there was just two of us doing everything. But at the same time, hey, at the time it had a market and the market changes and you have to adapt with it. And the standards were lower back then, and now the standards are higher because we're a more professional company and we adapt with the times, and that's good. But also, I think fear is one of the things that stops people from entrepreneurship. It depends on the country. I think in Europe, in general, Spain in specifically, we're very afraid of failing, and that's a constant fear. I think I lived a lot of years in the United States, and the idea is totally different. Like, failure is very much even admired there. That hey, you try,
So it's
which is a big part. But here we're very scared, and we have to maybe change a bit of that mentality, saying, hey, of course, you're taking a risk. It's going wrong. But it's better taking that risk than living your whole life thinking, what if I had done it? And that's something we try to teach everyone and try to make it part of the corporate culture is, hey, you innovate. It sometimes goes wrong. Hey, doesn't matter. We go back to the old way and see how we can
It's
change
okay.
it again.
Yeah, I mean, and this is, I think, a European illness as well, right? We like to regulate first and then do afterwards when we have regulated the non-existing thing as well. So I can only echo that we should be doing more doing and less thinking, right? In this sense.
Yes, it's implementation is the key. Yeah, I completely agree. It's I was in breakfast a couple, well, actually a year and a half ago, with who is now the president of energy in Europe, just Teresa Rivera. She's Spanish, and she didn't have that role back then. I was hearing her talking about regulation of hydrogen, and there was no hydrogen implemented nationwide. There was no projects, and they were already talking about regulating hydrogen, which was very amusing because in many ways we try to be too ahead of things, and that's not a critique to her or to what the European government is doing, but more critique to us because we regulate our life on a constant basis and are too afraid to try things, and we start thinking of what would happen if I did that, then this is gonna happen, and you're already talking about the
worst
living in
possible
Mars,
outcome.
and you haven't even built a rocket.
Yeah, we are jumping to the worst possible outcome, and then it slows us down significantly compared to the US or China. Like the best example now is this whole AI race, right? We are not even on the map, and the US and China are light years ahead, right?
Well, French are doing okay. Not much in Spain being implemented, and in many ways, so that's also reality because in many ways, for example, nTeaser, bringing it back to our own terrain and bring it back, or AI. We could keep it AI. There's a lot of innovation that we haven't even come to the 20th century in many ways, and we're already thinking about the 22nd. It's in many ways there's so many similar things that could be done that bring us much closer to our point. I have clients that I have to teach them how to use an Excel and send a Gmail, which sounds incredible. At that point, I don't even need to talk about AI or DeepSeek or ChatGPT or the rest. 3 steps behind. I mean, so in many ways, we become there's a certain tendency, and I think this happens a lot, and it happens a lot when you're an entrepreneur, and that's something you have to fight against, is that you become so englobed in your own ecosphere and so involved in what you think that you make that the norm, and you start saying things such as everybody knows, we all know, and those are not very much the case, because when you talk to different people, you realize that people have different opinions and they share different opinions, and everybody has their own why. Even you don't have to go very far. Even if you ask your neighbor, they probably see the world a different way, and things that are totally obvious to you are non-existent. They never heard about that thing in their life. So in many ways, you have to try working and try mixing. I always tell the people here, people always use Warren Buffett as a great success story, right? He built Berkshire Hathaway, and it was a wonderful company, and he was super successful. And you say, and I think what was special, and something that I found very interesting is every day he goes to McDonald's and he orders his Whopper and his drink for lunch, which is not very healthy indeed, but in many ways that helps him stay in the world. And that is very different to a lot of billionaires that live at the very different life. He's very much here. He drives the same car, he lives in the same house that he lived when he was just a middle class American, and now he's a billionaire and he still lives in the same house, drives the same car, eats at McDonald's, and that helps you see what the world sees. And that helps him invest in Coca-Cola or in McDonald's when people were investing in a lot of Google, a lot of internet companies that went past in the internet when the internet bubble burst. So that I think that's very impressive, and that's an example that we all have to take into account.
It makes perfect sense. It reminds me of my first sales job. I had a really good trainer, and he actually told me, and this is a really good lesson I repeat to myself every day. When you're in a sales job, your job is actually not to talk, but to listen. So that's why you have the ratio of 2 ears and 1 mouth. So use it that way. And
you're there to, in very ways, for me, is that it depends on the sales jobs, but in many ways, unless you're selling Coca-Colas or Whoppers, the things that we sell are very complicated and have a lot of things. And in many ways, although you have a very wide value proposition, you start listening, we do this and we do that and we do this third thing and this fourth thing and this fifth thing. There's really one thing or two things that really matter to this specific client. And they're waiting for you to tell them that. But you have to listen to what they're looking for and say, hey, this is of my solution what aligns with you. And that's very, very hard to do because we want to tell them everything. And what we think is the best thing in our product, they find mine okay. So you have to step back and say, hey, what do you want? And then say, hey, I can offer you that. Or sometimes it's even better to be honest and say, hey, I can't do that, but I'll put you in contact with someone who can. And in that way, you don't waste your time pursuing a client that is not going to buy it from you. They don't waste their time trying to find out the way that your key fits into their lock when there's not going to be a match, and that's okay.
Exactly. And since we are talking about the product, let's maybe circle back to the technological side of things. So what new features are you guys preparing right now? What are you excited about?
What am I excited about? Wonderful. So I'll tell you about what I was excited about 2 months, because it's very easy to think, hey, what is the next thing? And what is the next thing? And what is the next thing? I'll tell you about what we're building right now, but I want to circle back to 2 months ago and the things we were building. 2 months ago, we launched in Italy. That was a big step forward, especially because with renewable energies, and this is a big problem when you have good European companies that try to move to the US or good US companies that try to come to Europe. That's something that stifles them, is that they operate in the US as if it was Europe, or they operate in Europe as if it was the US. So in Europe, every country is very different. Every country has their own regulation. And it's usually, we have a lot of regulation. So when you try to open Europe-wide, for example, when a US company comes and they open Europe-wide, they usually fail, or they only partially succeed, because every country in Europe has a very different regulation. In renewables, licensing, although it's decently similar across countries, there's always exceptions. There's always differences. If, for example, in Italy, there's a strong push to implement renewables close to habitable zones, close to cities, towns, roadways, industrial areas. So there's this special license called the PAS, which basically allows to build projects very quickly in areas located 1.5 kilometers away from any inhabited zone. Now that doesn't exist in Spain. And that's very important in Italy, because if you're able to build a project in those areas, then you can get through regulation very fast. While normal regulation takes a very long time. So learning all these characteristics that made Italy interesting was very, very, very exciting and very, very beautiful. And 2 months ago, we launched there. We have launched with 6 portfolios. I think the total capacity is a bit over 0.5 gigawatt. So it's a good start, and we're getting good offers. The clients are happy, both sell side and buy side. So we're doing a good stride there. We're getting projects constantly. I'm going to Rimini next week, where I hope I can talk with a lot of our clients. So it's very exciting.
That's a
in
great
parallel,
trade.
2 months ago, we decided, hey, what we want to do is move to other technologies, because wind, solar, storage are the key. And I really do think that European wide, this is going to be the year of storage, and this is going to be the year that standalone big battery projects, not the ones you have in your house, but really the very large ones that give support to the
Utility
net,
scale, yeah.
the grid, very much similar to nuclear power. These are the year that it's going to be implemented on a huge scale. But we also want to go into other e-fuels are becoming very interesting, especially biogas. There's a lot of biogas implemented in France and in Italy, but in Spain it's a very new technology. And there's a lot of opportunities. We launched 2 weeks ago with our first operation plant, and it's going really well because there's interesting to invest in those technologies.
And just for the audience, can you recap on which markets are you currently in Europe?
So we're currently in Spain, and we are also operating in Italy. And those are the countries we have. We've been a Spanish company, worked very, very Spanish based. But a couple of months ago, one of our clients said, "Hey, I want to bet on Italy because Italy is the market, at least European wide. The market for renewable energies right now is Italy. Of course, Germany and Spain still hold the crowns. They have a lot more implementation. They have a lot more projects. They have a lot more production. But as a new upcoming country, the pretty girl on the blog is Italy right now in many of our eyes. And that's where we bet. And talking in the future, there's a lot of things to do. Of course, there's a point of innovating downstream. So we have digitalized what we would call the competitive process, the process of being able to find the person who's gonna buy your project. But we want to also digitalize steps further, the stage of analyzing the project and seeing, hey, what is really here. So being able to produce data room, being able to produce due digits, also other things. We want to enter into new technologies. So right now there's a lot of work in hydrogen being done in the company. We hired an expert on hydrogen, and his objective is to see how our solution can be implemented into hydrogen projects, both operational but also in different development stages.
And currently speaking, what part of the life cycle of the asset do you guys cover? And do you start at the design phase, the operational phase, and
so
you go also beyond? Or
usually, and this is changed a bit, but all the projects we sell are from land lease and grid connection. So if it doesn't have a grid connection, we would just account it as a piece of land, and we don't sell lands because there's platforms that sell that. We want renewable energy projects, and to have renewable energy projects, you need a place to produce the energy. So a plot of land, and somewhere, if you just produce an energy, but you're not sending it to the grid, to the distribution transportation lines, then there's no business. It's not possible business because you can't sell it to it. So we do utility scale projects. The small ones we do is 1 megawatt. That tends to be around 2 hectares of land for anyone who's not in the sector. That's basically what we do. Around 2,000 panels. Panels are usually 500 watts. And this is a million. So just do the maths. And then we go up from there up to, I think the largest one we had last year was 0.5 gigawatts in one single portfolio. So that's 500 megawatts.
Single project.
I think the largest one we have right now is a bit over 200. So that's especially in battery storage, because batteries use very little land to put a lot of capacity because you don't produce, you just store in it. Then you have much larger projects, actually in countries where the regulation allows for this, such as Italy.
Wow. And I mean, the other day I was actually reading the news about, what's the difference between Europe and the US. In the US, they have plenty of land and quite streamlined regulation. And in Europe, we have the opposite, right? We have quite limited amount of land and then way more regulation.
We're the exception. So Spain, there's a lot of land. And that's why Spain has become such a hotspot, because Spain usually most countries in Europe are very densely populated. Belgium, Holland, Denmark in many areas. England is a great example. But Spain is a very big country and not very populated. So we have a lot of empty, we call it the empty Spain, where there's a very, very low dense population. There's certain provinces in Spain that have lower population per hectare than even the Sahara Desert. So it's very, very, very undensely populated. And we have a lot of plains. And that's why Spain has been a very good place to implement it, renewables. But it depends a bit. Spain is a bit like Texas. Now it's the European Texas.
And most importantly, you guys also have the sun as well. It's not like here in Belgium, and the radiance is a little bit different indeed.
Yes. So we have a lot of sun. It's a blessing. It's very much a blessing to have the sun shining. It's a very shiny country. With that said, it's the problem with that has generated is that we depend so heavily in solar energy that it makes our our business model for investors not as attractive. Spain has the lowest energy price in Europe, together with Portugal. It's not even close. It's very much very different. And in that way, what that generates is, of course, less incentive to invest, because although you have more hours where you can be making money, you're going to be making less money during those hours.
And when we are talking about making or actually generating the electricity, what is the tendency when it comes to storage? What percentage of your projects are either connected to storage or actually storage-based projects?
So I can give you, I'm just logging into the platform right now, and I can give you up-to-date figures with how much we're looking right now. And I can tell you a bit more about storage. I think this is going to, as I said previously, this is really going to be the year of storage, probably across Europe wide. In Poland, there's a lot of really good regulation that is happening in Europe. In Italy, of course, with the new regulated tariff for batteries, that it's going to be a really good bet. And then there's certain countries such as Spain, where you have overproduction of PV during the top solar hours, where batteries are not only ideal, but they're really much a necessity to really redistribute the energy production that's being generated. So right now, out of the 21 projects that we have right now on sale at this exact moment, this is not including all the ones we have in negotiation stage or that are in other stages of development, but really the ones that a buyer can go tomorrow and say, hey, I want to buy that project. We have 21 of those, and we currently have 8 that are battery, that have batteries. 3 of them are hybrid projects, so they use both PV and storage projects, and what we would call behind the meter. So projects that only produce energy by the batteries that are only charged by the energy that is produced by their adjacent PV projects. And in addition, we have the other 6 that are what we would call standalone battery projects. So this is projects that, the other 5, sorry, these projects that don't generate their own electricity. And what these batteries need to charge is they drain the grid when they need to recharge, and then they start providing
Discharging
the grid once the incentives are there to do so.
A small clip from Shane Lebow from PVComplete. I think the last year was quite challenging, at least here in Europe. We've seen some numbers plummet, partially also due to the interest rates and the financing side of things as well. How was the perception in the US? How was last year for you guys?
Yeah, I think the US is still, at least last year, was still riding the high of like the Inflation Reduction Act, that it was a massive force within the US in solar development. The tax credit increasing. And then you've also had kind of the rise over the last year of battery storage that has taken a lot of projects that maybe didn't work, or, regulatory jurisdictions that you can figure out. And now, because you're able to, store power at a cheap rate, it has really kind of changed the nature of solar development. But yeah, certainly whenever like interest rates go up, that is a challenge for a capital intensive industry, and solar is no different from that. I think just in the US, you've had some regulatory drivers that have been really helpful. And now, obviously, with now the new Trump administration, that's maybe changing. I think everyone at this point is kind of working under the assumption that the Inflation Reduction Act will probably be rolled back to some degree, but no one really knows. So I think people are like proceeding with caution right now, and I wouldn't be surprised to see like a slowdown within solar in the US. So yeah, another big headwind in the US as well have been California has been always like a bellwether state and a real big driver for solar. So I think it was in 2023, NEM 3.0 came around, where California changed the rate at which it compensates residential and commercial properties for their power. And so that was a big headwind, at least on like the residential and commercial side within California.
Indeed, and also I think and I feel that the residential side of things is always a little bit more sensitive to regulation, and then the more you move up on the ladder, the bigger the project is, the more stable it gets in terms of outlooks, and if you are able to deliver the project a bit more profitably. How do you see the development between the CNI and also the large scale segment of ground mounted projects?
Yeah, personally, like I've always had a real soft spot for CNI. I think it's this like beautiful challenge that it's like, CNI is, I think is kind of considered like the stepchild, or like the like, looked down upon kind of segment within solar. And I've always felt that like kind of the opposite, just because, CNI sits in the space where, hey, it's not as cookie cutter and it's not as standardized as residential, but it's also not as big as, community solar or utility scale. So it's hard to, justify the time spent to like customize to a specific project. But, I've always thought that's a really interesting problem to figure out, hey, how do we expand? How do we make CNI more efficient so that you can get through projects at a lower cost? But, as far as like the solar, I would say outlook, community solar has been the name of the game in the US, at least, where, a number of states now have legislation, regulations that allow for essentially the economies of scale of utility scale, but then being able to sell that power for retail electricity rates. So, the projects between the 2 to, let's say, 7 megawatt range that are ground mounted, that are maybe outside of population centers, so you have cheaper land, but still get to sell power for that retail rate that CNI and residential benefit from. So that's kind of been, I think a big driver of solar in a lot of places. Utility scale is obviously still really big in the US, but what you have seen is that transmission capacity is filling up. You have like long queues within that, and so interconnection is increasingly a challenge. I think storage has helped with that because now, in places like Texas where, maybe electricity rates were going negative at certain times, you're able to balance out some of that supply. But yeah, it's I still really am like always pulling for CNI, and I'm always encouraged when I see folks trying to attack that space.
I actually have some experience with that as well. I had some customers on the EPC and also the project developer side where, they were targeting larger portfolios of CNI projects. So, logistical centers, or maybe a full school district where you can actually roll out multiple projects at a time within kind of one project, and of course increase the margins a little bit as well. And what actually struck me, what you mentioned, is that you are able to sell the electricity at the rate of retail. That's actually presenting a quite unique opportunity as well, right?
Yeah. The challenge, obviously, where a lot of people have focused is like community solar. You're able to build at a lot cheaper costs and still be able to do that. So with ground mounted projects, but yeah, CNI, you definitely have that opportunity still where you're selling in, maybe at 13 to 15 cents per kilowatt hour versus what utility scale where you're selling to utilities at maybe 5 to 7 cents per kilowatt hour. So just a different value dynamic, and then also a lot of states have different incentives as well. But yeah, no, I think honestly a lot of the CNI growth to date has been from bigger box retailers or whatever it might be, saying, hey, like let's hire a solar company to go out and do 50 of our stores or 100 of our stores across the country. What I would be fascinated by, and I think anyone that's into sustainability or solar is like looks at a city and says like, hey, like a city like Los Angeles where I live, like why isn't solar on like every building, right? And like that's always a conundrum, and the thing that I'm like maybe I'm an idealist about, but just seems cool. And the reason why that's challenging, obviously, is that buildings are different shapes and sizes, and then you have different counterparties that are owning those different buildings. So you have like maybe some credit issues or whatever it might be, but you think that there'd be some way of trying to streamline that, or standardize it like you've seen in the residential space.
It's not like you have a lack of sunshine in LA anyway, so it would make perfect sense.
It's terrible weather here all the time.
But you actually mentioned something quite interesting. I read the other day that Amazon is actually the number one green energy consumer from a corporate side of things. And my personal expectation is that with the rise of the data centers and that need to feed the AI boom as well, they will need to consume more and more energy. What's your take on that? Or how do you see AI fitting into the puzzle or from a kind of hardware side of things?
Yeah. No, I think Amazon has been huge in solar. I mean, I even remember like some of the first solar projects I worked on in like 2014 that were for Amazon. And so they've always been investing in solar. And I think they just have like a lot of rooftop space, obviously with their warehouses. But, specifically, I think everything is moving towards electrification. You have AI, obviously, but then you also have EVs. And so, you're seeing just like the demand for electricity rising everywhere. And, I think data centers do provide like a really interesting opportunity because a lot of times you're developing those buildings in places that maybe like are less populated, maybe harder to get power to sometimes. And then also, with the price of batteries now, you can provide like a really consistent source of energy by putting solar on those big rooftops or maybe on, a piece of land next to it and then connecting a battery. And now all of a sudden you've taken away any sort of unreliability that you might have from the grid and given yourself like some stable operating costs for the next 20, 30 years because, hey, how much we're going to get for maybe, the AI or, the storage that you're providing there. And you now know how much you're paying for electricity because you've capitalized all that and you have your project operating now.
Makes perfect sense. And I mean, based on the latest data, by 2050, just to meet our current demand, we still need to grow solar by 1.9% annually. That's compounded. And just that's meeting today's demand. But to meet the demand that we will have in 2050, we actually need to grow by almost 5%. So it's still a long road to go, I think, to catch up with everything. Especially you mentioned EVs as well. Here in Europe, it's more or less impossible to buy a gas car, or it actually makes no financial sense because it's just so expensive, A, to buy and B, to run as well. And I think with this, you will connect more and more devices to the grid. So I think one step will feed the other, and it's going to be a full 360-degree flywheel of generating the electricity, maybe even storing in your battery. You can do a little bit of arbitrage on this Tesla had the auto bidder software as well to discharge back to the grid. But I think it's super exciting looking forward. And from the people I've spoken to, everybody's expecting 2025 to be the year of the large scale battery packs.
Interesting. Yeah. I'm here in the US, so I don't see Europe as much, but I didn't realize that it makes sense that, everyone's turning to EVs. I mean, I think even in the US, at one point, EVs maybe had, some sort of perspective from people being like, why am I not using gas? Like, I want to have a gas car. And now I think with like all the auto manufacturers doing them and the people actually driving them, being like, wow, this is actually kind of nice, like, or fast. They're, fun to drive. But you drive an EV, it's great. I think that's only another driver for solar. I mean, I think in the US, there's always been this like dichotomy, at least on the political right, about, hey, like, natural gas or coal versus solar. And I think what people overlook is that it's not either or, it's like kind of everything, right? Like, it's like we have to meet an increase in demand, and whether or not, solar is incentivized through, government regulation or, incentives right now. The truth is that like solar has quickly become the cheapest new cost of energy just because, people are getting better at it. equipment is becoming more readily available, and there is more supply of it. So
And speaking of equipment, let's touch on the elephant in the room. When we are talking about any type of hardware in solar, let that be the battery packs, the panels, the modules, China is always the big elephant in the room. What's your take on this? How do you see this progressing?
at least in the U.S., like yesterday was kind of a wild day for everyone. Just our president deciding to unilaterally just make everyone enemies. I think everyone was expecting some sort of tariff regime. I don't really understand the perspective or the reason, but I think it's definitely going to hurt the solar space, which we're going to have to figure out. There has been at least some, there has been, because of the Inflation Reduction Act over the last couple of years, a shift to more domestic content in the U.S. So some manufacturing capacity has increased. But yeah, it's going to be interesting to see where this chain reaction goes, because if the U.S. is starting to just bite everyone on trade, is that going to be a whole move for everyone to just increase tariffs wherever it might be, and try to put their guard up? So yeah, it's crazy times, and I think people are trying to, at least what folks I talk to are trying to buy up a lot of modules right now, to not only, I think, avoid maybe potential tariffs, but then also to safe harbor for reductions in the tax credit in the U.S.
So everybody started to stockpile already.
Yeah. Which, we had in the U.S., we had that dynamic during the first Trump administration before the Inflation Reduction Act, where you saw the phasing out of the ITC and folks were safe harboring a lot. And now we're seeing that again. I think the prevailing sentiment is that, hey, the Inflation Reduction Act will probably be repealed or at least watered down, but it'll be kind of phased out. So people are saying, hey, if we think that we buy these modules now, they'll be able to be grandfathered into the existing tax credit regime.
Yeah, we've seen some of that in Europe as well. And, in the European Commission is also pushing quite a lot on European manufacturing. But I think, at least from the people I've spoken to, the US is still a little bit more ahead in terms of manufacturing anything hardware related compared to Europe. We have a couple of scaling projects where we have, small capacities being developed, but it's nowhere near to cover the whole demand without China. So that's a really tricky situation that both continents are in.
Yeah. And, I think there has been like a pretty significant like manufacturing capacity like shifted away from China. Whether it's like in other Southeast Asian countries. And so it's not just China. I think, like, at least in the US, I think that there's a lot of modules coming from other parts of Asia. But, obviously now with tariffs, it's going to be a whole different game.
Yeah, indeed. So you can only pick a smaller tariff, not no tariff. So it's going to be quite interesting. One of my friends is actually quite active in India, and he was explaining me that India actually has this plan of, kind of following the footsteps of China in terms of making and manufacturing anything and everything. And they have some huge targets for solar. So they want to deploy something like 400 gigawatts of solar in the next few years, which will be quite interesting. But they are also trying to build their own manufacturing capacities domestically as well.
Oh, interesting. Yeah. No, I mean, it's crazy. Like, I mean, you look at the amount of solar that's being developed in China or has been developed over the last 10 years, like, it's pretty wild how they've really been like a leader in renewable energy development. And I don't think maybe people realize just like how much is being developed there. But yeah, I didn't realize that about China or India, excuse me. Obviously a big population there, and yeah.
Big and motivated population. And just for the folks out there, I think it's really, just to frame it, when it comes to China, you really need to understand that China itself actually installs more solar than the rest of the world combined. So the data is quite shocking. I was putting the sales plan together last year, and I was doing a lot of digging. And when you see the numbers in China, that's really, how would I put it? Surprising is the right word, or scary?
Yeah. I mean, obviously, I think it's a good thing, right? Like, we'd much rather that than like new coal plants. I think the reality is that China just has such a big population and so much like industry that they just build everything. So you have solar and you have wind, you have, you know, coal, natural gas, just to meet the rival demand for there.
Indeed, indeed. And if you had to make a bet, well, what direction would you say solar will go in the next 5 to 10 years? What do you think we will see when it comes to development, etc.?
Yeah. I mean, I think solar is at a place now where we're kind of on the other side of the cost curve where you're really kind of fighting a rising tide if you don't think solar is really part of the future. When I first joined the solar industry, it was called like alternative energy still, right? And I would tell someone I work in solar and they assume I was like a tree hugger or like, someone that was just like obsessed with the environment. And now, well, you see every major corporation, you see like every country having solar development happening. And that's just because of, first of all, modules and equipment coming way down in price, but then also just the reliability of it. The fact is that once you get a solar project built, it kind of operates itself. You want to make sure you build it to spec. Maybe you wash the modules and you obviously have to, maintain it to some degree, do preventative and maybe preventative maintenance, but it's not like, you're shoveling coal or or you're feeding new natural gas into a turbine. So obviously that's really appealing. And now that it's so much cheaper, I don't really see solar going away, even despite maybe these tariff headwinds or, IRA rollback or whatever it might be. I think we're at a place where solar's kind of has enough mass on the snowball and has a lot of momentum.
For sure. And I think in the next 5-10 years, if you look back to today, it's all going to be only a speed bump, and it's going to be much more simple to look at it at the other end of the hockey stick, right? And speaking of changing solar, how do you anticipate for the role of the solar manager or solar engineer to change?
I think a lot of this stuff is just becoming more integrated. I think when, at least in the past, I think it was such that you maybe had to have experts in each part of the solar company, right? Like maybe you had to have a permitting expert, or you had to have like an engineer, or, and I think now we're getting to a place where because of software, maybe because of AI, you're now evolving in that, and there's more contractors out there, that you're getting to a place where you don't have to have specializations throughout your company. You can rely on software to help you get through some of those more challenging places. So I think that's obviously a good thing for solar companies because it gives you more flexibility. And so I think I'm obviously biased here, but whether it's because you're able to benefit from like software like ours or other software, I think being a jack of all trades and understanding, the basics of how a project gets through, what the economics are, is always incredibly important.
Do you think we will at some point be able to automate everything of the solar design process, or will we always need a kind of final checkpoint with a human at the end of the process?
Yeah, we've thought about that a bit. Like like I said, we're integrating AI right now, and it's like, the AI system allows you to like ask a bunch of questions about your design and be like, hey, am I doing this right? How should I do this better? Or tell me things that I'm missing. And that's incredible. But their next step is being like, okay, log into our software and just tell the AI to design a project for us. Like, use our software to create a plan set. And that is definitely in the future, right? And so I don't think it will ever be full automation, just because you have this physical component aspect of solar where you still have a site, and yeah, maybe you can get drone footage, maybe you can get like really specific radar and helps you, but I don't think you're ever going to be in like a fully automated, hey, like a human just clicks go situation.
Yeah, and I mean, I've spoken to many other PV design tools in the last couple of weeks, and the anticipation is that everybody expects their tool or some tools to be 90 to 95% automated, so that it will propose you like an ideal scenario of your project. But at the end of the day, you will still need to tweak it a little bit to match your specs, right? And before you start building.
Yeah. I mean, the thing with solar is like every project is still its own snowflake. And whether that's because you're interconnecting into a grid that, there's less than perfect information on, or you're in a specific permitting jurisdiction, or you have a site owner with, different sensitivities. And I think that you're always going to need, like a good project manager and good developer to make sure the project gets done in a like profitable way.
And if you could fix one major inefficiency in the solar design space, what would it be and why?
I would love to see, the solar design getting more integrated with the other processes at a solar company. I think you kind of have like two streams at a solar company where you have like, hey, maybe you have like, legal or economic components or financial components, and then you have like the technical side, and those things interact at different times within the process. But from a like software perspective, you don't see those things interacting as efficiently. It's kind of like someone pulling specific information out or taking specific information into the design. And so, I think one of our goals is to how do we make the design more integrated to the actual like commercial and business decisions that folks are making every day.
Paul Grana of Folsom Labs and Helioscope. How did you guys actually mitigate the relationship between the sales guy and the engineer? Because I know, speaking from experience, the sales guy typically tends to oversell the project, and then then it falls on the engineer's desk, and the engineer's like, okay, if we are playing defense now, we need to defend this proposition, and we need to make sure that it's valid. So what was the feedback from that side?
Yeah, I mean, I would say that by and large, there were maybe, if you oversimplify, we would hear from two different types of customers. Type 1 says, we need to make it work. We need to figure out how to trust our sales team, and we need to give them the tools to be self-sufficient. And then when they go wrong, we need to correct. And that's the example that I gave, where the engineer would kind of tell the sales team to use Helioscope in the interest of more speed. There were also many customers where the engineering team would say, my sales team can't really be trusted, so I'm still going to do this, and I'm going to use Helioscope, and it's going to be great because it's going to make me 5 times faster, but I'm going to be the one to use Helioscope. So don't not every company did what I talked about of having both sides using the same tool. But the one thing that I would say is, and again, this is kind of an interesting kind of it speaks for a lot of software, contrasting Helioscope versus PVSys, which by the way was not our primary competitor. Like as soon as we launched and got this feedback, we really stopped going head to head with PVSys. But one of the interesting things about Helioscope versus PVSys is that Helioscope was much simpler in terms of how many knobs the user had in the product. PVSys has on the order of 100 different variables. Some are buried within a PAN file or an OND file. Some are very buried in a menu. They're not visible in the user interface. And we would often hear from our own customers that, like engineers, that it makes PVSys, to use video game language, the ceiling is very high. You can get very, very, very good at running PVSys. And what that really means is if you want to add 2 percentage points of performance, it's trivially easy to do that. There are 24 ways that you know how to do it, and some of them are very difficult to find unless the audience is skilled enough. And so you got all these battles about tweaking arcane physics variables. versus Helioscope, where it's much more straightforward. The pan file is the pan file. There is no way to edit a pan file in Helioscope. You can upload your own, of course, but you cannot edit an existing one. Another simple example, like the rotor shading between the modules is calculated based on the 3D layout. Whereas in PVSys, there's sort of one step to do the layout if you want to do the layout, and then a second step where you tell the software what the rotor spacing is. So that's like one of the most common ways that we would hear anecdotally that in the world of PVSys, people would squeeze more modules, but then ignore the sort of shading problems from squeezing more modules. I mean, it's just preposterous because like if you just do it all at once, then that just isn't even an option for an overly aggressive person. So all that to say, being kind of the same underlying math, but being a much more simple product made our engineers actually marginally more comfortable because there just weren't ways for the sales team to kind of turn the knobs and squeeze more production. Now, okay, there still was always something like we had a soiling variable. You could take the soiling to 0. You can make the soiling negative. So there were ways, but it's like there's way fewer of them. It's way easier to spot them if you're doing something that's weird.
And actually, what I'm really surprised about how PVSys kept up and is still kind of a market leader in yield simulation. They are really an academic type of product. It's not really a really user-driven or good UI type of product, and they are still kind of the industry benchmark. So it's quite surprising that we are talking 2012, 2013, and ever since then they made some incremental improvements, but the UI UX and the usability is not one of them for sure.
Yeah, honestly, I find that to be one of the very interesting questions in this moment. So just to talk about them briefly, as I said, as soon as we launched and realized that we were used more by the sales team than the engineering team and used more for the CAD layout than for the physics, we immediately stopped trying to say we are going to replace PVSys. We just said, you know what, we're going to coexist. And PVSys does deserve some credit or a lot of credit, and I'll describe it in 2 steps. One, they did do a lot of the fundamental academic research behind how we think about solar performance modeling. They didn't just take a research paper, they were the research team that did that work. Point 2, and this is a nuanced point that I didn't appreciate in the early days of Helioscope, is that for years, they were the only product on the market. And for years, every time the biggest banks, and by biggest banks, I mean the biggest engineering firms that worked for the biggest banks for the biggest solar projects, every time they found a discrepancy, they would basically call up Andre Mahmoud, say, please make these changes to your math. He made the changes. And so PVSys isn't just the first and the leading academic work. It then was refined with the help of industry, so to speak. And so it's kind of calibrated to the performance expectations that the biggest banks expect to see. And it's really hard to reproduce that, right? Like because they kind of earned that over years of getting that feedback directly from Black & Veatch and DNVGL, et cetera, et cetera. So now, that being said, that's how I've explained things up to this current moment. We're now in kind of a fascinating moment, I think, for the role of PVSys in the industry, because you actually have a number of new companies that are genuinely trying to combat PVSys head to head. You've got, and I don't want to take us all the way down this tangent, but just to like briefly put a pin on it, you've got the likes of DNV launches their own software product, Solar Farmer or Sun Farmer. I always forget that's Solar Farmer today. You've got API first companies. So there's a company that I'm a fan of called Daily Energy, based out of the US, essentially delivering PVSys over APIs. And for a lot of the largest companies, that's how they want to consume their performance modeling. That they build a process and the performance modeling just fits into their process. You've got players like PVCase building their own performance modeling because there are some pockets where PVSys is really struggling to keep up, and particularly with the way the sort of backside reflection is calculated, and particularly with trackers where you have very complex tracking algorithms on 3D terrain. It's incredibly difficult for PVSys to keep up with that. So I do think that it's possible that 5 or 10 years from now, the world has changed and PVSys might not have the role it does today, but it still might. And that's, again, like just like a fun moment for the industry, where there's plausible changes, but there's not a clear future of which one will become the dominant paradigm.
Indeed, and I mean, if you are talking about the present and the future, my expectation is that we probably will be working cloud-based tools only in the next 5 to 10 years, depending on how fast the change goes. But I really do expect the AutoCAD-based tools to go away at some point, because it's not that simple to use, and I think you can unlock a lot of potential by limiting kind of the user's possibility to tweak so many things, as you mentioned before. But what's your take on this? What do you see the CAD and versus the cloud-based tools to look like in the future?
Yeah, my personal, so it's a great question, and just to sort of tee up the framework, the way I think about it is, by and large, cloud is the right way in the early stages, and because there are two reasons for that. One is, but early stages of any process, residential or commercial utility, you have a lot of volume. It's the very beginning of seeing if the site is valid or iterating through multiple designs once you're zeroed in on a site. So you have so much volume in those stages that cloud is much faster. It lends itself to automation, and the fact that you might have some kind of precision loss or accuracy loss is not a big deal because you're still in the early stages. And then CAD later on is something that, yes, you lose some of the speed and some of the automation. Although again, PPKs automate some stuff, so I don't want to say there's zero automation in CAD. But it's more difficult to use. It is slower to use. The barrier to entry is higher. You have to be much more trained, but you get that precision. And so, given that kind of very rough two-part framework of cloud versus CAD, the way I see the future is that I see CAD I see 5 to 10% shifting from cloud to CAD every year. But notice that function is an asymptotic function. If it's going to be 10% every year, then yes, 10 years from now, it might be what is, 0.9 to the 10th. It's like half, but there's still something left over, like it never goes to zero if you're only taking 10% away every year. So my personal opinion, the best analogy would be CAD is like Excel. And in the same way that a financial modeling tool will be more powerful every year, there will always be something where you have to take it to Excel and build something custom in Excel for a new tax schedule, that the new tax codes in 2035, that you haven't built into your software yet. So there's always the frontier of complexity there. You want to go to kind of the sort of maximally flexible tool, and in design that's AutoCAD, and in financial modeling that's Excel. And so they will always exist, even if the cloud and the automation takes over more and more and more and more every year, just sort of very, very slowly. Now that's maybe there are people that disagree with me on both ends of the spectrum. So for example, the Terabase team, Matt Campbell runs Terabase, Terabase. I'm getting rusty because they have Plant Predict and a whole software suite. Their worldview is CAD is dead. CAD goes to zero. And so there are some people that have much more aggressive opinions that CAD will go away faster. And by the way, I'm sure that if you would talk to David at PVKs, he would have a strong opinion that CAD will remain strong for 5 to 10 years. So I acknowledge that that there's of course going to be a range of opinions here. But again, that's what makes it fun.
Makes sense. And if I had to put money on it, I would bet on. I would think similarly to you that we are going to shift towards cloud-based, also just for the automation side of things and AI and everything else. But I think for the truly large utility scale projects, you will still be using the CAD tool to do the final design before you start breaking ground and start building.
Yeah. And by the way, it's a good maybe just one point on that. By and large, CAD is not really used for residential design. And, even residential plan sets, you're seeing a big push in automating that in the cloud as well. So maybe that's another framework is at what scale systems will CAD go to zero? And it's basically happening for residential scale. And then perhaps it happens in small commercial, perhaps it happens in medium to large commercial, perhaps it never happens in utility scale. So yeah, it's an interesting way to think about it.
It's always a gradual shift, but maybe we got a little bit sidetracked. So segueing back to Helioscope. So we talked about the product, where you guys started and how you guys got it off the ground. I really wanted to dig into a little bit into the freemium side of things. You guys mentioned that you started actually offering it for free and people actually wanted to pay for it. So can we talk about that a little bit?
Sure. I guess the only clarification I'd use on the language is free was never the long-term approach. It was, so we always were going to charge for it. We just had a period of beta where we thought it wasn't done yet. And we just figured, hey, it's free for now. And then we'll essentially let you know when it becomes paid. And so, again, that went from 2012 to 2014. And then, yeah, I mean, as I was saying, I think that there was one thing that struck me. There's a term in economics, I think it's called a Giffen good, where demand increases when the price goes up. And usually people use that to talk about luxury goods, right? The Prada handbag but in our case, one other way to think about the story that I talked about earlier is, many users were kind of using it with one seat when it was free. And then once we started to charge for it, they increased their demand up to 6 seats, 7 seats, etc. And so it's a case where they actually expanded their usage of the product after we started to charge for it. And by the way, that still shows up to today, because I'm often talked to founders who are in that period where they're not sure when to start to charge for it. And I always tell them, based on this experience, just start charging now. And maybe some of your users will stop using it. And guess what? That's good information. They were never your core users. But if 20% of your current users keep on using it and pay you, now you've learned something very valuable. And they're giving you much more strong feedback because they're saying, okay, this is good, but I need this to take it to the next level. So you're getting much sharper feedback about where who really loves you today and what do they need from you next, versus the signal you may have been getting from customers that were never going to pay you, and they might be asking you for things that they were never going to pay for those as well. And so you want to really figure that out as quickly as possible.
You need to get rid of the opium, and I've been in similar situations in the past as well. And speaking of this quite important part of product market fit or pre-product market fit, how did you guys incentivize your users or customers or the beta testers at the early stages to give you feedback? What was the kind of incentive why they would actually dedicate their time to test your tool and to provide you that invaluable feedback to better it yourself?
That's a good question. We didn't have a formal program in that way where we said, hey, we really want your feedback. But for us, I think the reason that people gave us the feedback that they tuned into Helioscope was that, to be honest, the narrative of we're going to take down PV-cyst was a compelling narrative to a lot of people. And so in a lot of ways that people were sort of very interested to just see a new alternative to PV-cyst. When, in a market where there's just one product, the second product people want to give it attention. And by the way, even there, notice, if you contrast what I just said with what I said a few minutes ago, we were saying to people, we're going to be the alternative. We're the cloud-based, module level PV-cyst alternative, which means that we were getting feedback that was very PV-cyst style feedback. Once we launched, we had a lot of people using it for the CAD, for the design capabilities, for the CAD capabilities, and their needs were different. And so, there was a case where once we launched, it was a much, it was a reshuffling of what our top 5 priorities were. In fact, there was just to talk around that a little bit more. We had a lot of debates between my co-founder and I about, are we ready to launch? When are we going to launch? There was a world where we might have waited another year because there's just some sense of like, well, it's not good enough. We don't like it. We're not proud of it yet, and that's where obviously since then there's been a lot of feedback that like, yeah, you really should be not proud of your first offering. But just as importantly, we had real conviction that once we launched, we knew what the next feature was going to be. It was going to be a module level heat map that gives us the energy that every single module generates every year. Guess what? Nobody ever asked us for that feature ever. And so even though we were like, well, we know this is the next thing, but let's just launch the product and then we'll come back to this. But like, it was sort of like the very next thing on our product roadmap. We were very wrong. And so launching, again, it's what I said earlier. It gives you much better feedback from the people that are actually paying you, who are actually like looking to squeeze value out of your product. And then you get much clearer direction on what they're looking for.
But that also meant that you guys were more the exception than the rule, right? Because you had one type of buyer persona at the beginning, pre-launch, then you actually unlocked another type of buying persona post-launch, which gave you better and more iterative feedback on what to develop next. So it's really the exceptional case rather than the rule. And which brings me to the next question of, how did you guys evaluate, or how did you guys decide on what features to push next?
Yeah, so there, just as a global answer to that, but I guess there's a tactical answer and then there's just a more strategic answer. The tactical answer is that we tracked from early on every single feature request that people had. In fact, we would think of a feature request even if the customer didn't articulate it that way. In other words, if someone would say, oh, how do I rotate this in 3D, for example? Because in the early days, it was impossible. Like in 2014, something called WebGL did not exist. And that was what was needed to be able to do a 3D rotation in the browser. So in 2014, when people would say, oh, this looks really cool, but it's only top down, how do I rotate in 3D? Well, the support answer would say, oh, sorry, that doesn't exist yet. And the customer would say, okay, all good. They would just move on. Well, as far as we're concerned, that is a feature request. That is a data point that they want 3D rotation, So in that world where you take a very expansive view of feature requests, we had thousands. I believe it was over 10,000 and perhaps it was like 18,000. I forget precisely. Feature requests. And so anything we would be working on, but by the time we were like 1 or 2 years in, would have dozens, if not hundreds of requests, for that feature. And so in some ways, it's a relatively quantitative exercise. Now, it's not so, okay, great. Now you've got a list. You got a whole database and you've got your top 10 features. Then that brings us to the second step, which is there is also a strategic decision about which of those you actually build. And that's where the only answer is you just have to use your judgment. For example, there was, I'll use one very specific case. I was talking in the early days. I remember talking to one of the large European utility scale developers. I forget which one, but it was like a name brand utility scale developer. And I brought that feedback back, and I was like, oh, like this is a big company with a big budget, and these are their needs. And Gibbs, my co-founder, was like, I hear that. There's no way we're going to prioritize that right now. And he was right, because what he was essentially getting at was we have kind of initial product market fit with commercial rooftop and some people in residential and then a tiny bit in utility scale. But to satisfy utility scale, it's actually 5 to 10 things we have to do at kind of simultaneously. It's not just a single feature request. As soon as you do that one feature request, there's going to be 5 more right behind it. And they're not going to be happy until we do 1 plus 5, not just the 1. And so that was more about focus, saying, hey, we're going to build for commercial rooftop application first, and then we will come back to utility scale. And again, this is a conversation in 2015, but just those are the kinds of judgment calls that it's hard to give a generalized answer, because it's just as much about like, you just can't do everything at once. And, there are times when you want to establish a foothold in an adjacent space, and there are times when you should be doubling down and getting better at your core space. And, that's what makes the job, is figuring those out.
And from my experience, this is also one of those things that separates great companies from good companies, that great companies actually say no to their clients a lot of times, because then you have a clear vision of where you're going to, and you're not trying to do a shotgun approach of, okay, I'm going to satisfy buyer persona A, B, and C at the same time. And at the same time, you end up, not really doing or building a proper product for any of them, because you're kind of doing a 10% here, 10% there. And I think that's a very clever way of, focusing the efforts and saying no to the customers. Of course, it's nice to be really transparent about this and, communicate to the utility scale customers in this case that you're sorry, I'm not going to build this solution for you yet, because we have, bigger and more burning solutions to do.